Hello, welcome to this tutorial, which is going to be an intro to Unreal Engine 5. So this session was organized by the Game Jam, you might know, and because of some technical issues, the video wasn't recorded properly, so I'm re-recording again for those who missed it and want to check it out. So let's just jump right in. So I'm calling it Into the Unreal Engine because it's basically an introduction of the basics for everybody who's never seen Unreal before or want to change their engine from Unity so they can see how things are done in Unreal. I'm Pedram Safari, and let's get in. So I put together some links and resources. I wanted to do slides, but I thought this is more helpful for the game jam. Basically, I'm gonna go through some of the documentations that can get you quickly started on how to get your hands to the engine and start doing some stuff. So if you have the Epic Games launcher, yeah, which I assume so many people do because of the store, there is a nice tab for Unreal Engine, which includes all the sections that are related to G. So there are samples, marketplace, plugins, everything that you need are basically accessible here. You can find an engine version uh, that you like and basically let them install. And once it installs, it takes a good couple of hours. Uh, you can just launch it, and when you launch it, you should get a screen like this. So, which basically shows you some of the templates that are basically like useful to get you started. So there is the blank template with any without anything. The virtual reality one, which is the one that I usually use because I work as a VR developer with Unreal Engine, and have been for a couple of years. Uh, but there's also a first-person template and third-person top-down for strategy games or a vehicle, which is basically a racing template, and you have access to a car as your main character. So yeah, this is basically Unreal Engine 5.1.1. Um, the latest engine at the time of this recording is 5.3. But I'm gonna open the first person template and so we can see how the engine looks like. Um, yeah, so once you create your project, you should see something like this. When it opens up, you should have the first person map basically. So I took this a little bit when we were doing the session for the first time, but I'm gonna go through everything that I went through there, so we're not missing on any uh, basic points. So the list, if we go back to it, the next one is letter editor and viewport controls. So if you've never seen Unreal before, this is how it looks like. It's really pretty, in my opinion. And there's so many tabs that you have access to. So this is the way that I usually like to put my layout together. And you could change it however you like. If you're coming from Unity, you can pick your same style over there and basically switch tabs and basically try to organize them in the way that you're more comfortable with as you're working. So the tabs that I have usually are the outliner, which is everything that is in the map. So all these objects, everything that you see are an actor, basically. So every object in a map in Unreal is called an actor. And so basically, whenever we create something or we bring in a new model or we bring in a particle or a sound cue, whatever that is, it's called an actor. And here you can basically organize them and put them into different folders so you know what you're doing. The other really nice window is the content browser, which allows you to see whatever you have in the project or whatever asset that you have. So this is basically the same structure that you see on your Windows Explorer. So if you right click, you can go to Show in Explorer, and it opens up a tab for you, which is the same thing as you have for the project directory in Windows. So if I go back, you should see that I have a folder that is called UEFPS, which is the name of the project. And if I click in, this is the U project file that opens the project. But if I go into content, I can see all the folders that are basically visible inside the engine as well. So we have some of the first starter content that allows us to basically get things going because this is the first person template. I'm just gonna click and let you guys see how it looks like. So if you press play, you get control of the mouse and you can just look around. You can move forward WSD. As soon as you get to the gun, the weapon, you can just collect it and you can shoot it with the left mouse button. So if you press exit, it just gets out of the game. But yeah, this is ready for the in the template. But we're gonna see how we can do some basic stuff. And because if you're deciding to make your game in Unreal for a game jam, you just want to get to know uh, how things are working quickly, so you can put your ideas into the map. So the next step is to talk about the inputs. So the inputs in Unreal Engine 5.1 have changed. So if you used Unreal with 5.0 or any version before that, Unreal 4 as well, they used a different structure for inputs. So if you go to project settings, there is this section called inputs, which is what used to be the case for the previous engine. So if you see here, it says that the axis and action mappings are now deprecated. Please use the enhanced input actions and input mappings context instead. That is the name of the new system that is being used for 5.1 and any version later after that. So we're going to look and see what are those actually. So if we go to content, I have no idea where are them in the project. So a good way to find them is just search from the root. If I just search for inputs, I get some results that shows me some data assets that have been created for the input. So with the new enhanced system, you need to create data assets for each action. And I'm going to just go through it quickly so you guys get an understanding of how they're all connected to your input device, basically, whether it's a mouse or a controller. So we have data assets for here. For this template, there's shoot, there's jump, there is look and move. So, but there's also data assets for input mapping context. If you see, those were input actions, but these are context. So if we open the shoot, for example, we can see that this right here, I think there's getting small, so I'm just gonna open it up and just dock it right here. So you can see that this one is just defined to be a Boolean variable, and it consumes the input from your device, and the trigger event of it is if it's pressed. But there are other events that you can define. So there are hold, release, pulse, etc. But we don't need them so far for this action, so we just let it be. But there is also the context now. So if we open the context, we see that there is jump, move, and look. But there is one missing. So shoot is not there for some reason, which we're going to see later why. So this one, we can see if we expand the tab, you can see the jump is connected to the spacebar, which is the default case for so many games. Or the gamepad face button, touch one for mobile. But if you open the tab, you can see you have access to the mappings of so many devices. If you're a VR user, you have HTC Vive, you have Oculus Touch, Valve Index. And for mouse and keyboard, the good old mouse and keyboard, everything is there. You can pick whatever you want to basically implement the functionality. And if we check out the other one, the weapons, so we have shoot in here. So these are different contexts. The main reason that is we are using this new system for the enhanced inputs is to try to categorize context in different cases, and it's in a way more organized and flexible. So previously, it might have been easier to set them up, but right now they are easier to basically categorize and give them their specific context. So the default is basically the default movement, but weapons have their own actions. And for our character, we're going to make sure that they have the context added to them so they can follow the input actions. Um, all right, so we want to see how our character looks like. Oh, before that, I'm going to just go over the other stuff in the report. So on the other side, we have the place actor, which is also another window. So at any time, if you are not having any of these windows, you can also go to the window tab on top and just find them. And when you press on them, they open. You can just drag and dock it wherever you want. So the place actor is a good window to bring the basic stuff. So if you want like a point light, you can just bring it in and try to interact with it. If you want a basic shape, if you want a sphere, you can just drag and drop it. So it's good. It's useful for that reason mostly. Uh, onto the left, onto the right, we have the details banner, which is one of the most important windows that you can have open. So because every object that you click on the map, on the level, has a detail that you can configure and adjust. So right now, we can see that this little cube, the blue one right here, if I click on it, it has a static mesh, which is a cube. And if I press on this magnifier, it finds the asset for me in the directory. So it's right now under content, level prototyping, and meshes. We can see that it's called SM underline something. And then if you scroll down a little bit, you see there are materials. So this one has a blue material and it has only one element. Some materials have multiple elements, which allows you to basically control how they look at different like sides and parts. So if there is like a material that if there's a mesh that's complex, you can have multiple materials for different parts of it. And if you can simulate physics on it. So if I right now this is simulated physics, which is also pretty nice comparing to Unity, I would say, because in Unity I remember you had to like add rigid body or something like that. I feel like Unreal just simplifies so many things for you to get started and get your idea uh, down and just try to play with it and expand it. Uh, but we'll get into more of those comparisons. But for now, if I just uncheck the simulate physics and press play, you can see that cube right there is not dropping because it's not simulating physics. But if you notice the last time, it does drop to the floor because it simulates physics and the gravity on it is enabled. So if I don't enable gravity and press play, because the physics is simulated, if I go and like hit the object, it just floats because it doesn't have any gravity, but it does simulate physics. So it just moves forever. And there are like so many advanced settings you can play with. But these are the basics that we're going through. So yeah, there is also another thing that is useful. So constraints, there are basically locks that you can place on your mesh to lock it for a certain to a certain plane or rotation. If I lock the X and Y axis and try to press play again, and if I go to the mesh now, you can see that it doesn't move really because it's locked in the X and Y axis. But if somehow I try to like give it some force, you can see that it does move in the Z axis, and it does fly basically forever because it doesn't have gravity. Anyway, so these are settings that you can play with, obviously, and that leads us to the next section, which is the maximal characters and animations. So there are like two resources that I recommend for Game Jam, mostly if you want to like do anything 3D, I would say for animations and characters. One of them is Maximo, which allows you to find like characters and animations for so many of the basic movements. So I call it Maximo every time. I don't know. It's Miximo. So let me go to the website so I can show you. Um, it's of course powered by Adobe, but when you go to the website, you should log in, and when you do, you can download basically characters and animations. There's so many weird shapes that you can pick from prisoners, zombies, like dolls, whatever. Uh, but they all mostly follow the same skeleton structure, I believe, which allows you to pick animations and give to either of them. So if you go to the animations tab, you can select any animation that you like. So there is the defeated animation, which the guy is so hopeless. There is sitting and laughing. I have no idea if this guy is laughing. Apparently so. There are so many weird things. Jumping down, reaction, dying. You can pick either of them and try to download, and it gives you an FBX file that you can import. And when you do, they are in the form of a skeletal mesh. So everything that has an animation that is baked with it comes in form of a skeletal mesh in Unreal, and you will have access to the animation sequence to try to basically adjust it. Because you can change the frame point in the engine as well if you don't like the animation for whatever reason. Uh, but I mentioned the skeletal mesh, which we will see later. But right now, these assets, the cubes and the stuff, are not a skeletal, so they are static. Static meshes are just one part. Skeletal mesh, the best example is like a hand. So if you look at a finger, it has bones, which allows you to like basically change the shape of the mesh. So if this was my hand, if this was a skeletal, if this was a static mesh, this would be like this. You couldn't change it unless you had a modeling software like Blender. But if it's a skeletal mesh, you can bend the bones and like give them different rotations and locations. So like each finger has like two bones inside and like other bones that connects it to the rest of the basically body or mesh. Uh, but these are all static meshes. And if you open one of them, you can see that there is some collision settings, UVs, etc. There's so many things to cover, so I'm just going to briefly touch on them. So if I do go to show, I can show the simple collision that is on this object right now. So if you look, there is a green line that is surrounding this, which is the collision of this object. Uh, there is also the light blue one, which is for complex collision. So usually for most objects, simple collision is preferred if you want to simulate physics. So if you don't want to simulate physics, you can use complex, but of course it is heavier on performance. But yeah, so after that, we have bridge. So bridge is another good example of the and a store of assets you have access to, a collection. So in Unreal 5, lucky enough, we have it basically integrated into the engine. So it's Quixel Bridge. Previously, it was a separate app that you had to download, connect to Unreal 4 or 5.0. No, I think 5.0 had it too. But yeah, 4, especially specifically, you had to download it. And of course, you can also use it for Unity as well, I believe. But the point is, it's right in the engine for you as a window that you can open and have access to so many cool, realistic looking, mostly natural uh, assets, 3D models that you can just download and bring in, but they are heavy. So keep that in mind. There are some of them are like a couple of gigabytes. And if you like click on them, you can see how like large they are. So this one shows the size for you a little bit. And if you notice, there's like a little human over there, which is pretty small comparing to the mesh. You can bring them in with the new technology of Unreal 5, which is nanite. You can have millions and millions of polygons in your scene, and it just adjusts it for you, and it's beautiful, which was previously like basically impossible to have because the performance would be so affected by it. But also, not just the assets, you have access to a variety of materials, especially materials for the nature looking environments. So we have like the bark sprouts, and there is like so many like roots and ground textures, uh, and the stone, different like textures. There are like collections that you can choose and pick from, and you will be led into a collection that is suited for that basically category. So this is like contemporary surfaces. And if you go, you will see there are like different kinds of floors in like wall, which are pretty nice. They're really high quality. You can just download them like 4K, 8K, and bring them in. But I'm not gonna do that because we have so many else to cover. Okay, so next thing is meshes and collisions. We briefly touched upon that. Materials and textures. So the next step that we're going to talk about is that we mentioned that this guy has blue material. How did that come from? And so if you press on the magnifier everywhere, it always browse to the location of the asset that is being used. So if you look at this, it says material instance. The reason it says instance, it means that it is a child of parents that was created previously. So if you look inside, you can see that it has some parameters and it has a parent, of course. It's called msolid. And if we browse to that one, we can see what's in the same folder, and it's called material, not an instance. So if you open this one, now you can see that there are some like basically nodes in the spaghetti that is connected to another big node. And this is how you basically form functions in Unreal. So this instead of writing every single letter of code, there is so much that you can already do with these. And these are called blueprints, basically. I believe there is a plugin for Unity as well, which allows you to do this kind of visual scripting, and it's called Bolt, I believe. But I am so much in love with the blueprint system. Of course, the engine itself is powered by C++, and if you know C++ well, for which is like uh, the C++ of the Unreal, if you know that well, you can create your own nodes and tweak so many things that you cannot do. But for the beginners specifically, there's already so many things that you can do with this that doesn't need a line of code. You just have to see how you want to structure things and put them together and just get to it. So if you click on this one, you can see that it has a material zooming and a blend mode and a shading model. These are the main things that you should check for every material that you're creating. So surface model is usually the one that you use for basically all of the most objects in the map. And any object that has a material that is like you can see. There are like post-processing effects in light functions, which are like separate. So for example, like if you want to like create a flickering light for a location, you could create a material that is a light function, and then you could give it to your light. So the point light that we brought in at the beginning, you could create a material that is flickering, and then assign it to that point light, and then it would flicker. So like connected and nice. Um, the blend mode right now is opaque, which is like pretty solid. But if you want to have something like a glass, which is translucent and you can see through, you should go with translucent or mask. So when you choose either of them, you have access to opacity. If you choose mask, you will have access to opacity mask, which allows you to basically give it a mask to cover or not cover, depending on how you set it, as you're basically putting your texture on the mesh. So sometimes you have your mask ready and your texture ready, and you want only a certain part of the texture to be basically put on the mesh. So that's when you use the mask. Um, but yeah, so for now, we want to use just opaque, have everything solid, and the shading mode default lit. There is unlit mode for different variety of reasons, uh, and other shading models. So if you like, you have base color, metallic, specular, roughness, emissive, normal, whatever. So many things that if you have no idea about shaders and materials, that could be a career on its own. So there are people who have the responsibility of just creating 3D meshes and make them look good with materials and textures. So that's the whole thing to get into if you're interested in. Um, so, for example, just to briefly touch on some like basic stuff, roughness is the thing that allows you to create something shiny. So we can see right now this red is pretty shiny. So at the beginning, when you're creating the new material, like none of these are connected. So you have nothing on this side. There's literally nothing here, and you have this empty thing, which is black and not shiny. But we put this together in the tutorial, the first one. So I'm just gonna keep it in and try to explain. So you can like pick a static boolean. You can introduce one which is variable for you to change later. If you right click and just search for a boolean, you can have access to like a boolean or a parameter boolean that you can change in instances. So if whatever parameter that you define, you have access to change in an instance of that material. And some fundamental things that you need to do sometimes are done in computers in general with if statements. So for materials, the if statements are usually switch. So it's basically saying that if this parameter is true, use the red one, but if it's not, use this like gray silver looking one. So you can see if I just uncheck this, it switches between these two. So you can find switch again the same way, right click somewhere empty and just type in switch. You have so many stuff which will take some time for you to get used to, and like which are the ones that you mostly use. Uh, but yeah, so like this static switch is the one that we're using here. And if you hold M and press left click, you get a multiply node, or you could again search for the multiply node right here. And yeah, so when you want to create something that is basically trying to have two logics together, you could use multiply. So for example, here we wanted to create a glowing material that's called emissive, which has emission. So we want to say that we want to have a parameter that is for emission intensity, and we want to give it to this material. So notice if you do just emission, let's say 10, you get a white, basically glowing thing. And that is correct. That is like a light bulb that you see wherever. So if it's like trying to emit light, you see it like that. And if you like increase the parameter, it literally turns into sun. So it really affects a lot. Um, but there is one thing that is not really working right when you want to give it a color, because you have the true right here and it has the red, but because of the emission, you're basically losing out on the color, and it all turns to white. So no matter what color I have here, it could be like purple or whatever, it all turns into white. Um, so we're gonna just give this white one to the blue. Actually, it is already assigned to the blue, and you can see it's really high. So 1,000 was really high number. So one thing you might notice also here is that because these meshes are all an instance of the same mesh, and they all had the blue material assigned to them, they all change here. But if I want to change just one of them, I have to change that one separately. So if I right click, I can create a new material here. So there's new material, you're just gonna just keep the name as that. And if I hold 3, you can get a vector 3 node, which could be used for color. And if you right click on it and convert to parameter, you also get an alpha, which is for transparency, but it's also a parameter that you can change now. So I want to like change the color of this to just yeah, something close to red, let's say. Yeah, and we apply them. So now all the cubes that have this sun-looking material, I want to change this little one to the red. And you can see that this instance right now follows that. And because it's not following the default settings, you also get this arrow on the side, which allows you to reset whenever you don't want to keep the instance different from the other ones. So yeah, that's how you like, change the material and create some new ones. So let's keep this as like 10, just for the sake of the details, and try to multiply it with the color that we had. So the base color or base texture, if you have, could be multiplied with your emission to get the emission effect, but also keep the color. So we multiply and put that emission color in, and we see that we got the purplish pinkish effect on it, and the color is almost right. So technically, it is actually correct. So if you look at something that is really glowing, if it has a color, the bulb itself does look almost white because it is trying to glow. But the sides really actually give you the color that you're looking for. There is something that you can do to change. So this is a setting that was changed in Unreal. It was not like this in the previous versions, but to keep things more natural looking, they adjusted this change. But you can also always try to get the other one. How you would get an actual color that is glowing is through post-processing. So post-processing is a really nice effect, nice tool for you to add so many effects. So it's unbelievable. It's like you can add bloom, exposure, like chromatic effects and like dirt masks, exposure, image effects, whatever that you could think of, you could do with post processing. And one thing to make sure is that if you want it to always basically apply everywhere, you have to make sure it's infinite and it's extended to like infinite. Um, or otherwise, you would have to be inside the volume as the character to see the effect through that lens. But yeah, so let's try and adjust the color. So this one, if I do the apply, you have to apply all the changes always to get the right effect. There you go. You see, we get actually like a weird effect right now because it is not pink and it's not white. So there might be a reason for that. Mm. So if you search for post processing right now, you can say that there is a tone curve. So if we like change the tone curve, oh, by the way, the reason this is blue is because we are using the blue, and the blue already had the color adjusted as blue. So if I tick that off, it uses the default. So if it's ticked on, it uses the setting that you had set for the instance. But if it's ticked off, it just reverts back to the default, which is mSolid. And right now they're all pink. So tone curve amount is the one that is the setting that allows you to adjust that effect. So if it's on 1, which is the default, you'll see that it glows, but the center is always white. The mesh is always almost white because it's glowing. But if you turn it down to 0, you get the actual color glowing effect on the mesh. So that's something to play with. Obviously, you can just leave it in like 75% and get it like something in between. Uh, but default is 1, so we're gonna keep it as 1. Uh, Actually, no, just for the facts, we're gonna keep it as 0 because we're gonna change material when something happens. So the next step is to talk about blueprints and functions. So that's basically where you try to bring things to life and make them interactable. So everything in the map we said was an actor, but some actors are static meshes, which are the models that you bring in. Some are lights, some are sound cues sometimes, but most stuff when you're trying to make some logic for your game are blueprints. So blueprints are the way that you implement logic, as we talked about. And right now, if I, for example, check out this gun that we had, this does some stuff. So it probably has a function like implemented in it. If we right click on it, browse to asset, we can find it in the content in first person in blueprints, and it's called BP pickup rifle. So if we open the blueprint class, which is what it's called, um, it's loading. Okay, we can see that right now it has an event trigger called onComponent begin overlap. So this is because it's the Unreal template. It has some notes for you to try to follow and understand what is happening. So if you press C at any time in this area, you can get a like a comment section that you can wrap around your node and add a comment. So this is what exactly happening here. If you want to add comment anywhere. Um, and yeah, so this object, you can see it's for a sphere collision. And if you go to viewport, we can see our mesh. And there is a sphere, which doesn't look like a mesh, but it has some basically boundaries. And it is set to hidden in the game. So when you press play in the game, you don't see. When we were picking up this gun, we weren't seeing this basically sphere boundary around it. But what it does, it has a setting to trigger some events. So if you scroll down to collisions, collisions are a whole thing that you have to like really uh, be careful of and make sure what you set as what, because that's the way that things react to each other. Sometimes through overlapping and triggering some events, sometimes literally just for colliding and blocking objects from basically going through each other. So if you have a wall, the player shouldn't go through the wall in most of the time. So you set the wall to block the player. And each object has its own type and has some responses to each channels, which you can adjust. There are presets that are already defined. So if I say block all, it does block every channel as the one static object type. But if I do custom, it's just this, and I'm gonna just do Control Z to get the setting that it had. So what it had was query only, uh, but most objects are collision enabled. So if you have a mesh, it is collision enabled. So this one is collision enabled because it's query and physics. But this one only is just query the environment and the interactions. Um, yeah, so we can set the object to ignore static and dynamic, but overlap the pun. So what it does right now, this is what we put around it in the session to try to print something. So we wanted to say that, okay, there is a variable that we define. If you look down here, my image is blocking it. But if you like press on the Plus, you can define new variable. So we could call it this test or whatever, and it's a boolean, which is just true and false. But if you click on it, you can adjust it to float, integer, text, string, whatever, and you can change it to array. So it could be a data structure for you to collect a bunch of booleans or a bunch of like numbers for whatever reason, and try to use them later on. So we wanted to print just a number on the screen as a debug to make sure that things are actually happening and going through when you grab the weapon. So we went on and tried to look at the PP first person character. That is the character that the engine recognizes to use. So there is game mode and game instance uh, that every game has, and the engine tries to use those to see what basically character you're using as your like main pawn, and that is the thing that basically can receive inputs and basically your main character, just to keep it simple. Uh, and this one right here, when the event is triggered, you get some options to use some of the details. So there is the overlapped component, which is the sphere collision itself, but there's other actor, which refers to the other actor that in overlapped with sphere collision. We want to make sure that when the overlapped actor was the character, then the character picks up the gun. So we want to do a cast. So casting, this is basically what casting does. You do that to make sure that an object reference that you have is the object that you want it to be. So right now, if a wall was like overlapping this object, you this cast would fail, and it would say cast to BP first person character fail. But if it's the character, it goes through and tries to create keep a copy of that character and introduces a variable and sets it to it, and adds the weapon component. So what it does, it says that now add the custom skeletal mesh weapon component to our player character. It contains all the logic and input for the weapon. So this one does basically exactly what we want it to. So it gets the character and adds the weapon component to the character. So all of these logic are done through these nodes. You have to like set the target and make sure the flow is right. So in the middle of that, we wanted to say if that happened, if that was true, just print a variable to the screen. So we introduced an integer variable in the BP first person character. And now we're gonna open BP first person character and see that. So you can see that it has its own logic, a lot of logic that it's dedicated for itself. And in this one, if you look down, you can see the rate here, I'm hoping. And that one is accessible through this cast. So when you do the cast, you have access to all the functions and variables that are exposed to basically change them or like just get them or set them to new variables. And right now we just get it. So the rate was 5, is 5. You can see here, we cannot change it through here, but what we can do is can like drag from the first person character and try to set the rate variable. And you can see it just finds it to something. So if you do this right now, you can set it to something different. And if you drag drop from here into there, you can see that we can set the variable to 3 instead of 5, and try to copy that to the screen. And if you press play and go and get the gun, you can see the 3 on top left that is appearing in the pink color. And when you do print string, that's a good way to try to see how things are playing out. If there is a node that is never being reached through like in your flow. You want to know if the flow is actually the flow that you are expecting. Um, and I had just set it to like 20 seconds to stay, and then after that it just clears out. And you can change the color of it as well. But the other way to try to debug stuff is to do a breakpoint. So if I right click on this node and toggle breakpoint, it adds that little icon on top of that. And notice when I go and get the gun, it just quickly jumps out of the game, but still running. And it just tries to show me that where am I in the flow of the events and logic that I define. So this one, when we had the breakpoint on it, it says, okay, you reached this point. What do you want to do now? You can get inside and see how that looks, which takes us to the the other basically actor and goes through that, or we can get out of it and follow. And when we follow, we can see that it destroys an actor. So we want to stop and see what actually happened. So this actor removes this pickup actor from the world. So in like all games, most games, I believe so. That's like the standard of doing so many things. Is that when you find a new object, you're not actually picking up that specific object. What you do is you send a signal to get that object from the root of it, not that instance. You basically like acquire an instance for your own and get rid of the instance that was in the environment. It just creates that connection for you. So you destroy the actor, but just right before that, these just happens like so fast that you don't even like feel it in the sequence. That right before that, you give the player the weapon and destroy the weapon that is in the environment. It might sound a bit confusing, but the more like you try to do these attachments, you will get an idea of why they are like this. Uh, but yeah, so this is basically the end of logic for this one, and it destroys the actor. We get the weapon. Now, if you go look at the player a little bit, we can see that okay, this one has something different. It's called begin play, which is an event that just runs by default, fires when you when the first time the character is existing in the map. So for the player, it's right when the game starts, but for the weapon could be whenever you do something and the weapon spawns on the map. So that's when is the first time the weapon is on the map. So that's when the event begin play will launch. And it gets the controller, which goes back to the game mode and instance that I talked about before. And tries to get the controller and make sure the controller that the engine knows as controller is the one that you're using for as your player controller. Um, so these are like deep into the engine, but you can go find the file and read them. But basically, we're checking that the enhanced input local player subsystem, if it's valid, we wanted to have this mapping context. So we're going full circle to the input again. If we look at this, it's IMC default. And if you do the magnifier, it finds the asset for us, which was the input mapping context that we looked at the beginning, that had jump, move, and look. So we can see that when you do at the component, at the mapping context, you have access to those functionalities. And for the weapon, that also has its own context, which was the weapon. And yeah, so this defines the enhanced action for the look, which is like taking the X and Y values from the mouse and try to like add it to the camera for the character. The movement as the movement in the direction and the jump basically allows you to jump, which was the spacebar. There is so many components for this as well. Right now, it has the hand and just the camera. So yeah, that's basically all there is usually for so many of the first-person games. There is usually not a mesh for the body unless it's third person because you never get to see the body in first person. Um, but yeah, let's just jump real quick to the next stuff and wrap up. So the next thing is lighting. Um, oh, by the way, before we get away from the functions, there is the useful thing that you can create is that you can create your custom events. So if you right click and search for custom, you can create your custom event, call it like uh, just test, whatever. We don't know what we want to do for this. You just will say that test what it does. Let's say, mm, okay, so let's see. So this actor, right? Oh, actually, sorry about this. I wanted to do this with the rifle. So this is the pickup rifle. If we introduce it here and do test, okay, so let's do a save. Sometimes when you cannot save, you have to make sure everything is saved so you won't get compilation errors and it compiles everything properly. So let's now name this test. Oh my gosh. Yeah, because I did it in the other one, I have to go back and delete it. Let's do test two. Yeah, yeah, compile. Now this one, we want to say that if it's test two, what we want to do, we could make this look visible in the map. So we could get the sphere collision and try to set it from hidden to not hidden. And we define it. With this one, we don't check the hidden. This time we don't check the hidden. So when we are printing, we could say that we want also the test two to run as well. So now let's see how it looks. If we go grab this, oh, okay, so I have to get rid of the breakpoints because it stops the flow. But yeah, okay, so it's not quite visible because we are holding it. Let me maybe increase the size. Let's see if it's more visible. 100. Um, yeah, I'm gonna just do another print, so it's just easier for you to see. We can do like a print hello. Yeah, so yeah, there you go. So you get the help. But basically, I'm trying to say that there is so many things that you can do in the custom events, like separately, just to organize your structure of logic, uh, or for whatever reason. But you can see when we deleted it, it says it doesn't exist now. So we have to like get rid of it and try to compile again and make sure the flow is connected. Anyway, so the next one was lighting. Lighting, just very quickly. Um, that is also uh, a whole thing to get into if you're interested in lighting environments. So in Unreal 5, there is also a new like system called Lumen, which allows you to use adhesive materials uh, to light up your environment. But just to like go over the basics of the lights, I'm just gonna explain the basic point lights that you can bring or directional lights because that really like allows you to do more customization. And if you're coming from Unity, that is also like what you're more familiar with and you can play with easier. Right now, like this area is like the sunlight. So we have like directional lights, we have post processing, We have atmosphere, skylight, and exponential fog, which gives us the effect that we get here. So if I just basically hide this, make it invisible, um, it goes away and you can see it's all like darkness and it's like a solid line that just changes. But if you get the fog effect, it kind of gives you like a little gradient that is, of course, much nicer. And yeah, so there is so many parameters that you can change. You can change the intensity of the light, the color of it, make everything just really like you play with the colors. You can do so many things. Time of the day, intensities, source angles. This is basically your sun. Direction of light is your sun, so you can play with it like so much. All the parameters that you can change though are all accessible in here. So if I like uncheck the shadows, you can see there are no shadows here. So it's just kind of awkward. But the shadows, you can see how much they add to the feeling of the environment. If it doesn't affect the world, you can see that it's darkness. But you can now feel the lumen effect of how emissive lights can actually really like make your environment look nice. Um, Although they are emissive materials, basically they're not really lights, but they could help you with like lighting up your environment a little bit. Um, but yeah, so the last thing is the settings and build. So we before that we want to like do a little quick thing of some action. Um, a little blueprint code that just makes us change the color of this when we shoot it. And let's say we want to just also make it like move to left and right a little bit. And if we just hit it, the color changes to back to blue, let's say. Um, so I remember I created something around here. So if we go to this one, I think it was blueprint. Um, yeah. So if you right click on that, oops, you get shoulder in view, show in the folder view. Show through. Yep. So I created this one. You can always create it on right click, blueprint class. It gives you a list to pick from. You can always select actor for whatever object you're not sure what it's going to be. It doesn't have a specific parent. You can always go with actor because all of the objects are actors. And pawn and character and player controller relates to game mode, which if you want to learn more, you have to like really go read about it in documentations to get a good understanding. It's not something really to quickly gloss over. Uh, but the character and pawn are the things that you control. So right now it's the first person character that we have. Um, and yeah, so if you open the blueprint that we created previously, what we did was that when you open it, it's like this. It's empty. There's nothing except these three, which for you to which are there for you to just quickly use, but you can just get rid of them. There's nothing. There's even tick that I'm going to quickly explain, and that is it means that if an object is in the environment, it's gonna run on every frame. So if right now, if this guy is in and I press play, you can see the hello is just printing infinite amount of times because that object is in the map, and on every frame, every tick, it tries to print hello. So that's basically the tick. Try to be careful of how you're using tick because it can get heavy and really affect your performance, downgrade it. Um, and yeah, so for this one, what we did was that we had none of these two. Just gonna rename it right now. It has no name. Um, so let's say collider. Yeah. So this is a spherical collider. Of course, you can add it here if you search for collision. You can get box collision, sphere collision, capsule collision, whatever you like. Right now, this is sphere, and it is visible, so you can see it in the game as well. And the cube that we had previously. So the static mesh is there, the material is set. It doesn't have physics, and yeah, we just did some collision settings for it. So if we type here, but sometimes you want some like simple animations, but as like programmers, usually uh, there are so many people that cannot do animation, myself included. So if you don't have access to any modeling software, you just want some simple animations for rotation, or just movement of changing positions and stuff. There's a really cool thing that you can use. It's called timeline. So timelines are basically timelines. So you can define some keyframes for it to go through. If you open it, you get a new tab in Blueprint. And if you do track, do float, you can define a float variable or vector, event color, anything. So let's say we wanted to just, there are like curves that are defined previously as well you could use, or just keep like create your own. If you right click, you can add a key value always anytime. But we just want two, so we just want to keep the middle one the end. And we're going to make sure the length is like 2 seconds. And the beginning starts at 0, 0, 0 times 0 value. And the end is like time 2 and the value 1. And we can see the curve just nicely goes up. 2 seconds. And that's what we got here. So we can always just right click and change the name of it. I'm just going to name it like alpha. And what we want to do is to just do some interpolation, So if you look for lerp, which is linear interpolation, you get a node that allows you to pick like a point from A to B and then increase it based on your timeline. So there are like two ways that I could do it, but I prefer this because it's easier than just dealing with the keyframes. So in there, this is like my A point, this is my B point. And what I could do is that I want this, basically the root, let's say, the root variable. I wanted to go left and right. Actually, no, let's like change the scale of it. So it's like different a little bit. So let's say we want this to set scale. So we can change like set relative scale. And it gives us the node that we can adjust the scale for it. So because it's a scale, you should keep in mind that it's better to just never set it as 0, 0, 0, because sometimes the engine just loses it and then thinks like it doesn't exist anymore. So you can never really come back up from it. So what I do, I usually like just to avoid any issues, I do like 0.001 and do 1, and I connect the alpha. So it right now goes through 1, 0, 0, 1 to 1 as the timeline is proceeding. So if I, for example, like introduce another variable that is like this, then this flow of time is applied to this alpha. And when I open it, when I connected it to basically the scale, it connects that vector to that float to a vector 3. So it applies to X, Y, and Z. And I connected to update, which means that every frame that this timeline is going through, we're going to update and adjust. And yeah, so we're going to connect it to the overlap and say, actually, no, let's connect it to the begin play. So it starts happening right when it does. And we want to make sure it's looping. So if you go in there, you can press loop and use the last keyframe. So right now we can see the icon is looping. So it means that whenever we play from start or from reverse, it goes from 0 to 1 and again it starts to go. So we want to play and see how it looks actually. So you can see there's something there that is changing. So this guy is changing. Yeah. and the loop is basically starting from the beginning. So whenever it reaches to zero, just quickly jumps back to when it reaches to one, quickly jumps back to 0.001, and then it tries to follow the timeline again. If you want to adjust that, you could adjust the keyframe in the timeline so it goes up and down. So let's say like this would be like one, and then this is zero. So yeah, and right now it should like basically scale up and down nicely. So you can see it loops properly, correctly right now, and like scales up, scales down, scales up, scales down. It doesn't jump. So yeah, and then we want to say that whenever we hit it, so we added a collider and said, yeah, actually we used the mesh itself. So if you right click on any component you bring in, you can add an event that is based on what you want. So we had the on component begin overlap in the map, and because also we have on component end overlap. But we wanted to use the begin overlap to say that if you contacted with the projectile that is being shot from the weapon, then we want to just change the material, you know. And for this one, we introduced the new material, but let's say, yeah. So let's change the other one to the blue that we have wanted at the beginning. I think that's nice. Oh, that's green. Blue. So yeah, so we want to like change it from purple to blue as this is basically moving. So we get the gun and try to go at it and shoot it. And you can see as soon as we did it, it collided with the actor, the material changed. So yeah, that's how you basically form connections and try to implement logic. You can take this like in so many directions. You could change the location of the actor instead of the scale. So you could like change for look for location. There's relative location and world location, which to briefly explain is that when it's relative to an object. So if an object is a parent of another object, when you scale down the parent, the object scales down itself as well. But the world uh, setting is basically based on the world, so it doesn't really care about any other object. It's not relative to any of them. And yeah, so you get like a good example is that like if you want to like have a rotation on an object, if that is set to world, if you rotate the parent, the object is always facing up because the parent is not following the angle of the parent because it's just caring about the world rotation. Um, but yeah, so I think we are almost like I have no idea if it's been an hour, but it get some time in, and I believe we went through some things. And last thing is settings and build. So if you're done and want to get a build, you can just go to map and try to go to platforms and go to Windows package projects, and when you just click that, it starts to ask you where you do want to put it, and let's give it a location. Like this is the location that I previously used. It goes to Windows and it tries to like add it there. So if I like open this folder, you can see that we had a build last time. So yeah, so this is the build that you get. If you run this, you have the application. And when you just do select folder and it starts to get the package for you. And if you do show output, I have the window output here and the message log as well. So they can show you if there is an error or something wrong with the build. Uh, or if not, it just shows you the process that it's going through to get the build and package it. So it's baking lights if there are some, um, get the meshes ready and clearing the caches, etc. Or creating some. And yeah, there are settings that you can adjust for rendering for Android plugins. There are so many settings that you can access in edit in project settings, and you can get this tab. And rendering is really the one of the most important ones that you can adjust the quality of things, how they are being done. Right now, we're using Lumen illumination. The screen space was like the old uh, version of doing things for reflection mode as well. And we are using visual shadow maps. There are old shadow maps as well. There are so many aspects to these things that you go and learn from. And because it was pretty small, the project, the package is complete. So we have that. Um, but yeah, and then there are shortcuts that you can also go and learn and try to like get faster in your process. Like right now, like if you like click on object, you get the gizmo, and if you press on a space, you switch between the move and rotation and the scale. So the blue is obviously for like Z, and red is for X, and Y is green. And if you hover over any of them, you get the yellow effect that tells you that's the one that you're trying to do, trying to basically adjust. Uh, but yeah, hope this was helpful, and I hope this time everything is recorded correctly because I will not be doing it again. And yeah, hope the game jam was good for the people who attended, and thank you very much for checking this out. And yeah, bye.